Good evening. I am just stopping by for a little key. I want to look at tables and graph very quickly. Welcome again to Mr. Wilson Live. We're streaming from Kingston, Jamaica, and that's in the Caribbean. This is not my usual vlogging evening. That would have been a Wednesday, Friday, and Sunday. But tomorrow being our last show, I think it's really important for me to get this bit in. So we're looking at graphs and tables, and once we're going to be looking at graphs and table, there is some two words that will come to mind. The first being independent, and the second being dependent. Now we want to get those clear for our exams and be able to construct our graphs and our tables. So I'm going to be telling you a little thing about tables before we get into graphs, and I'm also going to allow you to construct a table very quickly and a graph from mere observation. Great. So if you're just joining, please be reminded to like, share, and of course, subscribe. Call on those persons who don't know that we're here this evening and that we're doing graphs and table. How really quick that we're going to be doing this evening. It might require a follow-up class, but of course, I'm sure that persons will be learning. So these two words, or it's usually three words, but we're going to be looking at two today. So you'd have heard about independent variable, dependent variable, and of course you'd have heard about control variable. So let us just explore, hi Jawawan, let's explore the independent variable, and I'm going to be covering it a number of times throughout this lesson. Be reminded that the lesson will not be very long. Now the independent variable is that variable that is changed by the researcher. So you want to find out something, so you're going to set up a couple of parameters to test your variable to see if it is true. Now, it could also be independent variable could also be represented as a variable that, if changed, will impact the other variable. So it's either the variable that is changed by the researcher, or that variable, when it is changed, it will impact the other variable. Now, the other variable here is going to be the dependent variable. And the dependent variable is definitely the variable that is affected by the change. I'm going to be throwing some examples your way, and I'm going to see how best we can figure out if we're learning. So we're going to be looking at two variables. I want to up on to the 2016 biology paper 2, and we're going to be looking at that graph very quickly. So on the graph, we were supposed to look at temperature and bubbles, or bubbles and temperature. And we want to find out which is the dependent variable and which is the independent variable. Bearing in mind, the independent variable is that variable that, if it is changed, it will affect the other variable, or it is usually the variable that is adjusted or changed by the researcher. So now we're looking at temperature and bubbles. We're representing this information in a table. We're going to represent the same information on a graph. Good night, Khan. Which is the independent, as it were, with these two variables, which is the independent and which is the dependent variable. So the bubbles or the temperature. Just tell me which one you consider to be independent and which one you consider to be dependent. All right? Good night, Alicia, good night. You see, we pop in now because we think that we have something very important to look at. There are some keywords we want to get in before we get to the exam, more so for those persons who are doing biology. But this graph table thing is pretty much for everyone, so we're going to be treating with that. So I just looked at independent and dependent variable. There's much more to be said about these two variables, so I want you to stay very close and listen and try to do the examples with me. So what I want to find out, good night, welcome to the show, everyone. Welcome to the show, everyone. This is a quickie, and I'm very, very happy to have you. I know you must have taken time from your busy schedule to, of course, be with me. So we're looking this evening a little tat on graph and a little tat on tables. We might have to do another class, but we just want to give you a little bit to quench your thirst, and then we'll move right along with it. So I started out by looking at independent variable and dependent variable, and there's also control variable that students are having challenges with. But I want to look at be dependent and independent variable. And I'm going to give you some constant this evening. Once you're seeing these in your experiment, you know exactly where to put them on your table and where to put them on your graph. So I'm going to hop right into it again. Please be reminded to like, share, and of course subscribe. So the independent variable is the variable that is changed by the researcher. So you change these parameters to see how it will impact something else. Or we could say that the independent variable is that variable that if it is changed, it will impact another variable, and the other variable, we call it the dependent variable. Now, the independent variable is placed on the x-axis, that's the horizontal axis of your graph. The independent variable is placed on the horizontal axis of your graph. The independent variable is also placed in the first column of your table. I'm doing HSB. I watch all your videos. Wonderful teaching. Great. Thanks much. Great. So the independent variable, once you get a table and you are going to put the information on your graph, then you need to know what is supposed to go where, or else the graph will have a incorrect shape and you won't be able to interpret the data well. So if you look at the 2016, I think we had 3 columns there. Of course, you could have used the first column, but you'd have to use a legend if you did that for the graph. Luckily, on the 2016 paper, it told you that what it was looking at was pretty much a number of bubbles and the temperature. So we then had to decide on that 2016 paper, what are we going to put on the x-axis? What are we going to put on the y-axis? So what I want you to do, based on the definitions I have just given you, I want you to tell me, we're looking at temperature and we're looking at bubbles. Which is the independent variable and which is the dependent variable? So we're looking at number of bubbles versus temperature. Good night. Fully understand plasma and serum. No, this is all right. Thank you very much. I'm not too sure what you said at the end. Thanks. Oh, thanks very. I'm not too sure. I'm sort of all where those things are concerned. All right. So you want to tell me now? Great. You're welcome. So I want you to tell me that bit because we're doing some examples, and after this class, this is going to be a short class. You should learn a lot. What is the independent variable versus what is the dependent variable? If that one is too hard, just tell me it's too hard, and I'll give you another one. Is it too hard? All right, I don't know if I'm logging, so I'll just quickly give you another. Top blue dependent. I'm not too sure what that means. I'm not too sure what that means. Oh. No, you can't just put temperature or things like that. You have to say which is dependent. So if you're saying that temperature is the independent or temperature is the dependent, then you need to know. Well, I need to know that mistake. So tell me what you're saying. Which is dependent, which is independent? All right, just let me remind you of the experiment. What they did, they had 7 test tubes in that experiment, and all the 7 test tubes were at different temperature, right? And they had catalase in a 1% hydrogen peroxide solution, and they were observing the amount of bubbles that is given off based on the reaction, and the reaction, of course, is driven by the different temperature range. So what we want to find out in that experiment, what was the independent variable? What was the dependent variable? All right, because we want to make sure that we know what is supposed to go where when we are constructing a table or we are pretty much constructing a graph. So temperature is the independent and the bubbles is the dependent. I am lost, sir. All right, that's great. Could you ask the question again, please? All right, great. We'll ask the question throughout the lesson. All right, so there are some persons who are with me and there are some persons who are lost. We are looking at dependent and independent variable, right? We want to have a clear understanding of these 2 variables and where they are supposed to go, that we don't have to jump over the next graph question that we're seeing on the paper. So I'm trying to treat with graph questions that we can have more students answering the graph questions, all right? Because in most cases, they are easy. Now, one of the key things that we need to know interpreting that table to get it onto the graph is to know what is to go where. Now, the information, usually if it's a table with two columns, the information in the first column is your independent variable. And the independent variable is placed on the x-axis, which is the horizontal axis. How do we know what is the independent variable? Because the independent variable is that variable which will be altered by the researcher. Or it is that variable that once you change it, it will affect the other variable. So what does that mean with the other variable that is on your y-axis or the dependent axis? You are not troubling anything over there, right? What you're doing on the x-axis will cause things to change over there. So let me just give you something easy that you can treat with. They say that you shouldn't overeat, right? Because if you overeat, what will happen to you? If you overeat, what will happen to you? Tell me in the chat. Tell me in the chat, if you overeat, what will happen? All right, welcome to my viewers and subscribers and those who are just stopping by it's Mr. Wilson Live. We're streaming from Kingston, Jamaica in the Caribbean. Usually we have a show on a Wednesday, Friday, and Sunday, but exam is upon us. And we're looking at those little things that are giving students trouble, and we're trying to erase them that more students can tackle some questions that normally they would not have. All right, great. So Alisa is understanding now. So if you eat a lot, then it's likely that you are going to gain weight. All right, independent variable changes causes a change in dependent variable. Great. All right, so let us go again. I want to look at this eating stuff because most person will relate to this. So if we eat a lot, we gain weight. Suppose we don't eat anything, or we eat and we practice those little things to, control weight. Suppose we eat or we don't eat a lot, what is likely to happen to the body? So if we eat a lot, we're going to get fat. Somebody said that you're going to gain weight. If you don't eat a lot, what will happen? If you eat less than you should, what is likely to happen? We're going to get it today. We're going to get them today. Everybody here is going to get it. It's going to be the last day that you're having problem with independent and dependent variables. All right. The body may get malnourished. That's a big term. I wanted to keep it as simple as getting fat or getting slim. All right. Gaining weight or losing weight. I wanted to keep it that way. So see if we can give us that answer. If you don't eat much, are you going to gain or lose weight? Let's keep it there so that those persons who are not probably so sharp or where we are, they can catch on. All right. Okay, they'll get slim. Great. Now, this is our exam that we're setting up now. So listen, if we eat a lot, we will gain weight. If we don't eat a lot, we will lose weight. Let me ask you a very question. When you are gaining weight, is you put on the weight? Yes or no? Do you put on the weight yourself? Like you get a knapsack and you put on this, advertisement, sorry. All right, so you get this and you pack on this because you're getting some weight, and you pack on this over here because you're getting some weight, and you pack the stapler over here because you're getting some weight, and you put on a Nixon bag over here. That's how you gain weight? That's how we gain weight? Yes, no? Yes, no? No, that was very easy. I want to find out how we gain weight. Oh, somebody don't know. All right, so let me ask you. I want to understand how we gain weight. And we're looking at dependent and independent variables. So if we eat a lot, we are going to gain weight. If we don't eat a lot, we are going to lose weight. That is what you say. So I want to know, if I were supposed to put a nice stroller on my head, This is an example of me gaining weight. Yes, no? Tell me in the chat because I want to take it off my head. So a nice stroller is on my head now. I want to know if I am gaining weight. Yes, no? You're being cruel to me. You won't even answer. I wonder why. Am I gaining weight now? Oh, great. No, I'm not gaining weight. Where am I going with that? The gaining of weight had nothing to do with me putting on the physical weight. It is the same thing when you are looking at the dependent variable. You as a researcher, you have nothing to do with it over there. What we did, all we did was to eat. So you tell me now, which is the dependent and which is the independent variable? So we're looking at two things now. We're looking at gaining weight and eating food. So which is the independent? Is it gaining weight or is it eating food? Which is the independent, which is the dependent? We're looking at those two variables, eating food and gaining weight. Which is the dependent, which is the independent variable? Tell me in the chat. You have to tell me what gaining weight is. Is it dependent or independent? I suggest that everyone answer. It's going to be a real practical class. I'm a real practical person. I'm one of those teachers that you'll see standing on top of the desk to explain something or jumping off a desk to explain something. I am that type of teacher. You've never seen me in action, but that's me. All right, great. All right, so gain weight is independent. You think? All right, great. And what's the dependent? Eating food is independent and gaining weight is dependent. All right, so one person have it right, one person have it wrong. Let us go back to the definition. Independent variable is that variable that is changed by the researcher. What are we changing here in order to gain weight or lose weight? The amount of food that we eat. So what we are manipulating is our consumption. So if we eat a lot of food, we are going to gain weight. If we eat just a little bit of food, we are going to lose weight. So that which we are manipulating here is the independent variable. Because as a result of changing the independent variable, the research are changing the independent variable, then the dependent variable is affected. You start gaining weight or you start losing weight. I remember when I use the stroller, it's not the researcher that is putting on the weight. It is happening as a result of what happened on the x-axis, the independent variable. So the dependent variable is responding as a result of what is happening with the independent variable. Are you with me? So the changes that we're seeing on the y-axis is as a result of the changes that are taking place on the x-axis. So we are eating food on the x-axis. So on the y-axis, we start gaining weight. Are you with me? More consumption, more weight. More consumption, more mass. More consumption, more mass. All right? So there we have one. So now that I've said that to you, let me just bring you back to something. And I'm going to give you some real things that you really can't even put on graph, but you have to find it out. So let's get back to the bubbles and the temperature. With the bubbles and the temperature, which is the dependent and which is the independent variable? Bubbles and temperature, which is the dependent, which is the independent variable? All right, having a problem with that still? Having a problem with that still? You have to answer all these in order for me to understand that you understand it. All right, so temperature here is going to be the, oh wow. So Chan is not understanding. Mark, do you speak a second language? Is English your native language? I see you always typing something and I don't understand. Forgive me if I... Bubbles are dependent. All right, plumber temperature is independent variable, and the bubbles are the dependent variable. All right, good night, Campbell. Good night, good night. All right, so let me just give the answer for that. No, I can't give the answer. I have to continue until you find it. I'm going back for the stroller. We're looking at eating and we're looking at gaining weight. If I eat a lot, based on what you told me, I'm going to gain weight. So what I'm manipulating is the amount of food that I'm taking in. If I don't eat a lot, then I am going to be losing weight. Sure. Yeah, a little high. So if I eat a lot of food, I am going to gain weight. If I don't eat a lot of food, I'm going to lose weight. But if I don't eat a lot of food, and I was supposed to put a nice stroller on my head, does it mean that I'm gaining weight? Does this mean that I'm gaining weight? I'm not eating a lot of food now, and Joseph is eating a lot of food. And I see that Joseph gaining weight. So suppose I was supposed to start walk around with a nice stroller. Does it mean that I'm gaining weight? No, it doesn't mean that I'm gaining weight. So here what we're trying to look at is that on the x-axis, where we're eating the food, we're doing some manipulation there. That is the independent variable. Now, depending on how much food we eat, it will change what is happening on the y-axis, which is gaining weight. Understand? So here, we're looking at temperature and bubbles, right? It is as if you are cooking. If you increase the flame under the pot, will we have more bubbles or less? If we increase the flame under that pot with that dumpling, if you are in Jamaica, are we going to have more bubbles or less bubbles? The boiling effect. Tell me in the chat. I want you to answer everything. What are we going to have? We're going to have more bubbles. Now that we are cooking, we can control the flame. But do we put a hose in the pot and blow in the pot for the bubbles? Do we do that? Yes, no? When you are cooking, is it that you put a hose in that water and you go, I have a straw here. So I put the straw in my pot because I want it to bubble up very quickly. And I, and I blow. Is that what we do? Yes, no? No, that's not what we do. We manipulate the temperature, right? So we determine, oh, turn on that pot for me because I'm going outside to talk to somebody and I don't want the food to burn apart, the pot to boil over, right? So that which we are manipulating on the x-axis, as it is temperature, is the independent variable. The bubbles are the rate at which a pot is boiling is the dependent variable. All right? So then, x-axis is temperature and bubbles on the y-axis. As the temperature increases, so does the amount of bubbles. Perfect. Perfect. So let me give you another one. We're now looking at fertilizer, that plant nutrient and plant growth. Which is the independent, which is the dependent? Fertilizer and plant growth, which is the independent, which is the dependent? Which is the independent, which is the dependent? Great. Which is the independent, which is the dependent? Fertilizer and growth. We are now looking at nutrient being applied to the soil, which is dependent, which is independent. Independent is the fertilizer, and the plant growth, I assume, is the dependent. Let us explain that. Fertilizer is the independent variable, and the plant growth is the dependent variable, because it depends on how much fertilizer you apply to that plant. It will grow very quickly, or the fertilizer might kill it. But then you can't just go out there and hold a plant and pull it out like an elastic for it to grow. No, it doesn't work like that. You can't physically, you don't physically change what happens on the y-axis. You do that to the x-axis. Whatever variable is on the x-axis, the variable we call it independent variable, that's the variable on the x-axis, that's the one you can manipulate. All right, great. So I'm going to give you another one. Water and the growth of plant, which is the independent, which is the dependent. Water and the growth of plant, which is the independent, which is the dependent. I think we're steaming up to this thing and I'm liking it. We have to get this before we start talking about tables, more so graph. Now we're looking at water versus plant growth. So water is the independent variable and plant growth is the dependent variable. Independent variable, water, growth, dependent. Water, independent. All right, great. Because you can manipulate the amount of water that you are adding. I want this to grow very quickly. I put some more water. I don't want it to grow. I don't put any water, so it'll become retarded and, of course, slow growth, stunted growth. All right. So water here is the independent variable and the growth is the dependent variable. The growth will be determined by the amount of water that is applied. I'm going to give you this one now, and then I'm going to hop right into the tables. Which is the independent and which is the dependent? Study and grades. You're looking at study versus your grades. Which is the independent? Which one affect which one? So we're looking at study and we're looking at grades. Independent versus dependent variable. Which is the independent and which is the dependent variable? Study is the independent variable I'm seeing here. Study the independent and grade the dependent. Anybody else? I don't know. All right, study independent, grades dependent. Okay, great. Your grades are dependent on your study. You see it's coming on nicely. All right, study is independent and grades are pretty much dependent. That is so nice. It is as easy as that. All right, so now that you've been so wonderful, what I'm going to do for you, I'm going to make it a little easier for you now. Usually, time, temperature, and pH are represented on the x-axis. Time, temperature, and pH is represented on the x-axis. Write down that somewhere for me. Then on the y-axis, usually height, mass, numbers as in frequency, rate of an activity is represented on the y-axis. So this is like a formula getting into the exam now. I am not going to worry about anything. Where's the number changing? On the y-axis. Am I manipulating what is happening over there? No, I manipulate what is happening on the on the x-axis. Great. So remember, on our x-axis, we are going to have time, temperature, or pH. On our y-axis, we are going to have height, mass, numbers, which could be in frequency, and rate of activity. So when we spoke about the number of bubbles, that is the rate of activity. All right. When we spoke about, when we talk about numbers, it could be, so we're counting persons. Over 1 hour period, how many persons walked past? All right. How many cars drove passed by? How many bike passed by? All right. So that's numbers. All right. So those are stuff that you want to really, really have in your head getting into the exam. So I want to talk a little bit about tables very quickly. I think I would have been here for half an hour, but it's a little over half now. Please be reminded you're watching Mr. Wilson live. Please also be reminded to like, share, and subscribe, and join us for one of our shows or one of our many videos. Should be able to assist you in getting ready for the exams. So the dependent variable is that variable that is affected by the change, and the change is taking place in the independent variable that is usually on the x-axis. So x-axis, independent variable. Y-axis, dependent variable. When we are constructing a table, there are some guidelines that we need to pay attention to constructing a table. The first thing we need to know is that tables usually have 4 sides. That's the first thing you need to get in your head. Please do not draw the table on the margin of your books or on the margin of the paper. So tables have 4 sides. Usually you're getting about 4 marks to construct and populate a table in the exam. A table must have a title, and above the table, the title should be written in uppercase, that is capital letters. The title should be descriptive of what is in the table. So when I read that title, it must tell me exactly what is happening in the table. Once I read that title, it must tell me exactly what is happening in the table. Then we get on into the table. The table should have a header column and a header row. And the same is true that the header column will tell you what is in that column, and the rows will also give you a nice indication as to what is populating the cells that are associated with the rows. Another thing you need to know about tables is that you should not repeat the units in the cell. So you have column 1, and you are looking at time. You do not write in that column time, 10 second, 20 second, 30 second, 40 second. You don't do that. You write the number coming down in a straight line, and then in your header column, you are going to put your second and put it in curve brace. So we know that time, and it is being measured in seconds. All right? So you use that symbol to represent time. Now remember, time could be measured in second, minute, days, year, week. You have to determine what you're using. Another thing about tables is that in some cases, you might have cells that are blank. The cells that are blank should not be left blank. If there's no data to populate that cell, a dash should be drawn in the cell. It should not be left blank. Do not use a 0 to populate the blank cell unless 0 is a part of your data set. So if you found nothing, then it is 0. But if you have nothing, then it's a dash. Make sure you are doing correct representation. When you construct your table, always be reminded that the first column of your table is the column that will carry your independent variable. It is your independent variable from the table that you will use on the x-axis of your graph. In some cases, CXC would have represented the title for your table. If it is represented, then there is no need to go writing it again. Are you clear on that? Usually, the title of a table can be used for the title of the graph. All that needs to be done is to change the name table showing to graph showing. And if there are any other modifications to be made, then of course you can do that. There are some abbreviations that you can use with table. You could use in the table ND, which means no data. And if that is used, if you're using an abbreviation in the table, then you must put a key below the table to capture what the abbreviation means. Try to use a pencil to construct your table. Try to use a pencil to construct your table. Make sure that it is neatly drawn and accurately represent the data set that you intend to represent. The information from a table is usually used to populate a graph. There are primarily three types of graph at your level, with the exclusion of pie chart, that you'll be populating. There is what we refer to as a bar graph, or some might say a bar chart. There's also that which we refer to as a histogram. And lastly, you will look at the line graph. By no extent of our imagination, these are the only graphs that can be represented. But in most cases, these are the three types of graphs that are represented on the CXC examination. The bar graph. The bar graph is used to represent data in which one variable is numeric. The bar graph is used to represent data in which one of the variable is numeric. The bars have no relationship. They stand by themselves. A part of a bar could be shaded to show a portion of a set. A part of a bar could be shaded to show a portion of a set. So a bar graph, the bars usually don't touch each other. The bars are usually have the same width, but they are not of the same height, unless the data set dictates that they should be of the same height. Like all graphs, all the axes must be labeled. We must ensure that there's a directional line on the graph that shows the direction of increase. So here we have a little arrow, here we have an arrow, or you might choose to draw an arrow on the outside. When you are representing a graph or representing data on the grid, you should always try to use 75% of your graph paper. If you observe that drawing the graph on the outer side of the grid will not allow you to cover 75% of the data of the graph paper, then move your graph more towards center of the graph paper. Remember, you are going to label the axis. The name for the axis will come from your table. You are going to choose to pull it from your header from your header column. Of course, the first column or thereof, or whatever that data is asked to be represented. Now that you can make a judgment as to what is dependent and what is independent, the independent variable will go on the x-axis while the dependent variable will go on the y-axis. Not only should we name the axis, but we should also place the unit of measurement on the axis. So if we're using temperature, we need to write TEMP. That's temp, full stop, and then the unit in which the temperature has been measured. We measure, yes, the unit in which the temperature has been measured. Degrees Celsius, definitely not Fahrenheit for CXC. On the frequency side, which is the y-axis, so too we must have the unit of measurement. If you have more than one curves on the graph, oh wait, we're not at curve. I'm upping out of bar chart. So that pretty much tells us that which we need to know for the bar chart. So the bar chart, our bar graph, we could represent different data set and a column by doing shading. We must also be reminded that they bear no relation, so no prediction can be made. If we're doing genetics, then a bar graph is used to represent discontinuous variation. So there's no midpoint in such data set. Histogram. A histogram is used to represent a data set in which both variables are numeric. However, in most cases, when we use a histogram, we are using a range on the x-axis. No prediction can be made with a histogram. And of course, the bars of the histogram, they are touching each other. In the case of the histogram, the bars are touching each other. So remember, a histogram is used when both variables are numeric. The histogram is used to represent continuous variation if we are looking at genetics. With that said, let's look at the line graph. The line graph is used, to show relationship between two numbers. So now we are looking at relationship, how one variable affects another. With the line graph, prediction can be made. If we have more than one curve on the graph, as if we were comparing renewable and non-renewable energy sources, we should make sure that each curve can be properly identified. If we're using a line graph and we're going to plot the coordinates, I'm not even sure if they are called coordinates. Wherever the points intersect, if you are using a dot, the dot is supposed to be circled. So here's my dot. Here's a dot. Can't leave it like that on the graph. You must ensure that it is circled. Once it is circled, then you should not be making any error in plotting a point that is not a part of the graph. You could also use asterisk to note the points to be plotted. You could use small triangles to plot those points as well. Usually, I don't know that they'll be giving you more than 3 to construct at CXC, 2 I think maximum. There is also a time when the data set is so large that everything cannot be accounted for on the graph paper. In that case, we break the graph with something that looks pretty much like a lightning. There are 2 things that I know that can be used. So this area, the graph is broken like this. And if you are supposed to follow the graphs on my channel, the past paper, you'd have seen this symbol, or there is another symbol where we're using just 2 lines that run parallel to each other. So we could use this symbol, or we could use this symbol. So we could, this little thing here like a lightning, we could use this here, or we could use this here to break the graph to ensure that everything is accounted for on the graph. Please go to my channel and check out the graph questions that I would have done, the past paper question, single question on graphs. So we would have looked at the bar chart in a minute, the histogram in a minute, and of course the line graph in a minute. Please be reminded that your graph should always have a scale that pretty much tells the unit on the spread. In some cases, you might be required to construct a key that will better help us to understand what is represented on your graph. That takes us to the end of the lesson for this evening. I promised that it would have been very short. We are 15 minutes over short, but I'm very happy that you stopped by to learn. Do we have any questions or concern before I say good evening? Any question, concerns? Are we asleep? All right. So if there are no questions or concerns, I take this opportunity to remind you that I am Mr. Wilson from CSEC Biology TCP or TCP Academy. We are covering biology and human and social biology for the CSEC syllabus, CXC CSEC syllabus. We're streaming from Kingston, Jamaica, and we're on air on a Wednesday, Sunday, and of course Friday at 5:05 p.m. We have approximately 300 videos on biology and HSB on the channel. To access them, all you need to do is to click that blue button below this video that says CSEC Biology TCP, and you can be treated to animations, live lessons, labs, laboratory skills, and of course, other videos and animation that should help you with your growth. There are also mark schemes and messages from CXC, so much there to assist you in acing your exams. So please be reminded to like, share, and subscribe if you find what we're doing to be helpful. Just let me check before I go. Could you show an example of a scale? Great, I can do that. All right. The one on the left of the table is usually the independent. Left, this is the left, so I am looking at my table like this. So the left is going to be here. This is going to be the independent variable, and that's the one that goes onto the x-axis. When we talk about a scale, simply put, if I don't know if all right, great. So a scale pretty much tells how much of what you are measuring, how much it is represented by on your graph paper. So a scale would say something like, it's usually just a little rectangle at the top with scale written on the top, and it might say x-axis, it might have a colon, and it might say on the x-axis 1 centimeter represent 10 degrees Celsius. Let us go there. 1 centimeter represent 10 degrees Celsius. So we know that for every 1 centimeter, it will increase by 10 degrees Celsius. And then below that, we'd have the y, and we could say on the y-axis, 5 centimeter would be equivalent to probably 10 bubbles. All right, so that's all that the scale says. It tells you for each centimeter how much of the value that you are measuring, you are testing, you are experimenting with. For each centimeter on your graph leaf, how much does this variable represent? All right, how much centimeter represents the variable that you are measuring? So here I'm saying on the x-axis, 1 centimeter represent 10 degrees Celsius. I'm also saying on the y-axis, 5 centimeter represents 10 bubbles. And that's a determination that you are going to make based on the information that is given to you or what is required of you. Sir, can you explain allele? I was hoping that you wouldn't go outside a graph this evening. I won't talk about allele. The easy way to recall is that they tend to determine trait somewhat like genes, or they tend to carry the trait. Right? So there's an allele for just about, like you'd have an allele for tall, you'd have an allele for short, you'd have an allele for fat, you'd have an allele for slim, you'd have an allele for black, you'd have an allele for brown. Now, if they are the same, we say that they are homozygous. If they are different, we say that they are heterozygous. Now, all these definitions, they worth 1 mark on your exam paper, and these are things that you need to study as the definitions for genetics. If they are heterozygous or homozygous, these carry real meaning depending on which of the genetic diagram you are asked to cover. If you are looking at inheritance of dominance, then once the dominant allele is expressed, then the phenotype will be that of the dominant allele. Now, if you are looking at inheritance of recessiveness, then the individual can only acquire the recessive condition if they acquire the homozygous recessive gene. So they must acquire it in the homozygous state, meaning that they must get two. If we're using S to represent the allele, it might be 2 small s. All right. So it's very important that you understand these terms: allele, genes, heterozygous, homozygous, chromosome. You need to understand these definitions getting into the exams. And these are usually like 1 mark question. And they really don't carry a lot of mark, but the definitions, you need to have them in your head, because if you have them all locked, as we would say it in Jamaica, you should be doing well. Sir, is 1 male and 1 female? No, alleles have nothing to do with male and female. Alleles have to do with trait. Trait. All right, so allele is not a male and female thing. A male or a female could have an allele, but an allele is not a male and female thing. I strongly suggest that, being that you're asking that question, that you type in the word allele in Google, do some reading on it, and if you're not satisfied, see if you can go on over to YouTube and watch a video on allele, because you're really, really a little distant away from the term. And I think you need just more than what I'm saying now. I might be way over your head based on the question you've just asked us now. It might be a little way over your head what I'm saying now. So I suggest that you do some reading on your own. Consult a textbook, consult Google, watch a video on YouTube, type in the word that you've just asked me to see how best you can get some assistance there. If it's not working, then the next time you see me, you talk to me. And then if we have to do something for you, we'll definitely do that. All right. It was great being with you this evening. I again took a little time out of night time to be with you. So until tomorrow evening, where we're going to be looking at sewage and population, hopefully this is going to be our last class. Take care of yourself and be early for the class, because we're going to have a lot to cover. Good evening and thanks for joining.